So, review. We're starting with Unit 1, Section 1, Order of Operation. Order of operation. You have to remember BIDMAS. B stands for brackets. I stands for indices or exponents. Exponents is the American word. D stands for division, multiplication, addition, subtraction. Addition and subtraction go together. They could be, we could have said first subtraction, then addition. They're interchangeable. They're at the same level of importance. Division and multiplication go together. They could be in the opposite order. It doesn't make a difference. But brackets are definitely first on their own, and indices are second as well on their own. I'll show you what I mean by doesn't matter if you put division or multiplication first. Look at this example. If we say division comes first and then multiplication, in this case that would mean division comes first, so we do this bit first and then multiply it. So this would mean 6 divided by 2 is 3, so we multiply 5 by 3. That's 15. If we said multiplication comes first, we would do this bit first and then do the division. 5 times 6 is 30, divided by 2, right? Division comes second. That also gives us 15. That's what I mean by these go together. Their level of importance is the same. Same with addition. You could think of your own example to show that it doesn't matter if you do an addition first or the subtraction, right? Yes. Okay, so an example is this. If we don't put any brackets, we would solve this problem by doing the multiplication first. 5 times 2 is 10, and then we add the 1, which gives us 11. If we put brackets around this addition, now the addition becomes more like we have to do the addition first because it has brackets and that comes before multiplication. So we first do the addition, which is 2 plus 1 is 3. So now we have 5 times 3, and that's 15. So watch for brackets, watch your order and do whatever comes first. Okay, next. Directed numbers. This refers to negative and positive numbers. I have some examples here for plus and minus. These are easy problems, right? But we have a positive 6 here that we start with. So our starting number is positive in all cases here. If we did 6 plus 5, that would be 11. Now if we add a negative 5, that means we're actually subtracting the 5, which makes 1. 6 minus 5, that's easy, right? That's 1. And we notice that it's the same as the previous problem. If we're adding a negative number, we're basically just subtracting the number. Now we're going to have 6 minus a negative 5. Subtracting a negative number is like adding that number in its as a positive. 6 plus 5 is 11. So see how this one and this one give us the same answers, and this one and this one give us the same answers. So basically, subtracting a negative number is like adding the number positive, and adding a negative number is like subtracting that number as a positive. Okay, with multiplication, if you multiply a positive number by a positive, you're going to get a positive number. If you're multiplying any positive number by a negative number, you'll get a negative answer. If you're multiplying a negative number by a positive number, you'll get a negative. If you're multiplying a negative by a negative, you'll get a positive. We don't care what kind of numbers, this is always true. So as you notice, multiplying plus and plus will give us plus. Multiplying negative by a negative gives us a plus. So if these two signs are the same, you'll get a positive answer. If the signs are different, you'll get a negative answer. Same for division. When you're dividing a positive by a positive, you'll get a positive. If you're dividing a negative by a negative, you'll also get a positive. So when these signs are the same, you'll get a positive answer. When the signs are different, you'll get a negative answer. Again, it doesn't matter how big or small the numbers are. As soon, just the signs tell us this already. Okay. Factors, multiples, primes, squares, and cubes. Just the short version. When we want to find the highest common factor or the lowest common multiple of two numbers, we draw a factor tree. In a factor tree, we're finding only prime factors. Let me just remind you how that's done. For 270, we're going to make a factor tree. We start with the lowest prime number, which is 2. Does 2 go into it? Yes, it does. 2 times 135 is 270. We try factoring out that 2 again. That wouldn't work, right? Because it's an odd number. It's not divisible by 2. So we move on to the next prime number, which is 3. And 3 actually does go into it. 3 times 40 is 120. And 3 times 5 is 15. So there we go. Now, is this divisible by 3? Again, it actually is, because 3 times 15. Is 15 divisible by 3? Again, yes it is. It's 3 times 5. Oh, and we're done because we notice this 5 is also a prime number. So we're done. So 270 could be expressed as 2 times 3 times 3 times 3 times 5. The same with 420. Start with the first prime number, which is 2. That goes in 220 times. Well, this is obviously divisible by 2 again. 105 is not divisible by 2. So we move on to the next prime number, which is 3. 3 actually does go in 35 times. Yes. 3 doesn't go into 35. Next prime number is 5. 5 goes in 7 times, and we're done because 7 is a prime number. We can't divide a prime number. We can't factor out any other factors, right? That's the definition of a prime number, is it's only divisible by 1 and itself. Okay, so 420 could be expressed by saying 2 times 2 times 3 times 5 times 7 is 420. Okay, now to find the highest common factor, let me use red. The highest common factor, we look for common factors, common prime factors in these factor trees. Well, they each have this 2. They each have this 3. This one has more 3s, but this one doesn't. This one has a 5 that this one also has. So 5 and 5. We've now circled all the ones they have in common. They each have a 2, a 3, and a 5. So 2 times 3 times 5 is the highest common factor, which is 30. And I'm about to write 60. It's 30. Yeah? Now to find the lowest common multiple, we use blue. We cross out the ones that we found in common only on one of the factor trees, right? These are doubles, so we cross them out on one of them. Now all the factors that we have left, circled or not, as long as they're not crossed out, we multiply those together. So this 3 times 3 times 2 times 2 times 3 times 5 times 7. And you will find that that is 9 times 420, which is, oh my goodness, 9 times 4 is 100 plus 180. 3, 7, 80. I hope that's right. You can correct me later if I'm wrong. I'm not wrong. No, it's right. Okay, so this is the lowest common multiple. You could get questions, remember the question with the light bulbs? There's a light bulb and it flashes every 8 seconds, right? There's another light bulb and it flashes every 6 seconds. When is the first time, like they start at point 0, they start flashing together. When is the next time that they will flash at the same time again? That is a question that asks for the lowest common multiple. We know that this one will flash at 0, right? Because they start at 0 by flashing. It'll flash at 8 seconds. It'll flash at 16. It'll flash again at 24. It'll flash at 32, etc. Right? Notice how I'm not using a factor tree right now. I'm just going to make it. I'm going to do it by just listing the multiples, right? Here, this one's going to flash at 0. They both flash at 0. It flashes at 6. It flashes at 12. It flashes at 18. It flashes at 24. Right? So the first time they flash together is after 24 seconds. That is an example question of when, like a real life question, when you need lowest common multiple. And because these numbers are easy numbers, we can do it by just listing the multiples. But when you're working with bigger numbers or ones that are just that don't reach the lowest common multiple this soon, you use your factor trees. Okay.